Solving a system of linear inequalities is like solving a system of linear equations, but instead of finding the variables that make the equations true, we're going to find the variables that make the inequalities true. So if we look at these two inequalities, we have a system of inequalities. If I tested the point 0, 0, if I plug 0 in for x and 0 in for y, I can determine if 0, 0 is a solution to that inequality. Well, when I do my math here, I get 0 is greater than negative 7. And 0 is greater than negative 7. So 0, 0 is a solution to this first inequality. And if I plug 0, 0 into my second inequality, and I do my math, I end up with 0 being greater than or equal to negative 12, which is also true. So 0, 0 is a solution to both inequalities. If I try a point like 2, 4, I plug 2 in for x and 4 in for y, and I do my math. 4 minus 7 is negative 3. Is 4 greater than negative 3? Yes. Plug 2, 4 into my second inequality. Do my math, I have negative 8 minus 16 gives me negative 24. Is negative 24 bigger than negative 12? No. So 2, 4 makes my first inequality true, but my second inequality false. Let's try another point. 3, negative 7. Plug in 3 for x and negative 7 for y, and do my math. 6 minus negative 1, or negative 7, is negative 1. Is negative 7 greater than negative 1? No. Plug 3, negative 7 into my second equation, and I end up with negative 12 plus 28, which gives me positive 16. Now, is positive 16 greater than or equal to negative 12? Yeah. One last point that I'm going to try. 9, 0. Plug in 9 for x and 0 for y, and do my math. 18 minus 7 is 11. Is 0 greater than 11? No. Plug in 9, 0 into my second equation, and I end up with negative 36 minus 0, which is negative 36. Is negative 36 greater than negative 12? No. So if I'm looking for the points that make both equations true, there's some points that make neither inequality true, some that make one inequality but not the other, some that make one but not the other, and some that make two. So what I'm looking for is all of the ordered pairs that make both inequalities true. Well, if you remember, a linear inequality has an infinite number of solutions. To show all of those solutions, we're going to use a graph. So I'm going to graph y greater than 2x minus 7. My slope is 2, my y-intercept is negative 7. I'm going to connect these points with a dashed line because it's all of the points that are just up to this line but not including this line. That's what the greater than without the or equal symbol means. If I look back to the beginning, I have tested some points. I tested 0, 0 and it worked, and I tested 2, 4 and it worked, and I tested 3, negative 7 and it did not work, and I tested 9, 0 and it did not work. So I want to shade all of the points where I have solutions to this inequality. 9, 0 was a no. 3, 3, 7 was a no. 2 was a yes. 2, 4 was a yes. And 0, 0 was a yes. So I want to shade to include these 2 points and not these 2 points. So all of the points in this region make this first inequality true. Now I'm going to graph my second inequality. Solve for y. A positive divided by a negative is a negative, and 4 divided by 4 is 1. A negative divided by a negative is a positive, and 12 divided by 4 is 3. So my y-intercept is 3, and my slope is negative 1. And this time I want to connect with a solid line, because I want to include the points on this line as possible solutions. And again, I need to shade. But I've already figured out some points to shade. If I look back to the beginning, 9, 0 was a no, 3, negative 7 was a yes, 2, 4 was a no, and 0, 0 was a yes. So I want to shade to include these 2 points, but not these 2 points. So looking at my graph, my 2 lines have divided my graph into 1, 2, 3, 4 regions. This point, or this region over here, are all of the points that make both equations false. This region right here is all of the points that make just this equation true, or this inequality true. All of the points in this region make just this inequality true. And all of the points in this overlapped region make both inequalities true. So if I'm looking for all of the solutions to this system of inequalities, I want all of the points in this region right here, in that overlapped region. So I'm going to shade that region in nice and dark so I can tell that this is where all my solutions are. So I have an infinite number of solutions, and they're all the points in this shaded region. And I have an infinite number of solutions. any ordered pair that's in this region is a solution to this system of inequalities.